mathematics class. This class is for 9 and today we will be starting a new chapter, that is chapter 12 in your textbooks, named Pythagoras Theorem. And we know that you have been studying Pythagoras Theorem since long in your earlier classes, but today we'll start from the scratch. First of all, Pythagoras Theorem is applicable to right angle triangles in your level. So what is a right angle triangle? Any triangle in which at least one angle, any triangle in which one angle is 90 degrees. Suppose I take a triangle ABC and I say in this triangle ABC angle B is 90 degree. It means that this is a right angled triangle, or it is a right triangle in which angle B is equal to 90 degree. Now its sides have different names. Always the side which is opposite to 90 degree, this side is opposite to 90 degree, it is known as hypotenuse, and the other two sides are known as legs. In out of these two, one is known as base and one is known as perpendicular, but that is not required, so we will not go into that discussion. Only you need to remember what is hypotenuse, and hypotenuse is always the side which is opposite to right angle. So in this triangle ABC, AC is hypotenuse. Now we will move on to the Pythagoras theorem. They say that in a right triangle or in a right angled triangle, the square of hypotenuse, this is the hypotenuse, so hypotenuse is AC. Square means it's a square. A square of the hypotenuse is equal, to the sum of squares of other two sides. So other two sides are AB and BC, and they say that the square of the hypotenuse is equal to the sum. So sum of square of these two sides. It means this is what we have to prove. Suppose we have taken a triangle ABC, so we have to prove that AC square is equal to AB square plus BC square. In a right triangle, the square of the hypotenuse, that is AC, so I have written AC square, is equal to the sum means addition or plus sign of squares of other two sides. So other two sides are AB and BC, so square of AB and square of BC. Now we move on to the proving of the theorem. Now first of all, how do we prove anything? First we write the statement. So statement is already written. In a right angled triangle, the square of hypotenuse, now in this figure it is BC, is equal to the sum of the squares of the other two sides. So along with the statement we will draw the diagram. We have drawn the diagram. Now we generally write given. So what is given? You can see that a triangle is given that is right angled and at A. So you can write a triangle ABC right angled at A. This all you can see. And this is where you can mention one more thing, where BC is the hypotenuse, or you can say with BC as hypotenuse. Then second thing is what is required to prove. You know that hypotenuse square, that is BC square, is equal to AC square plus AB square. This is required to prove, so we are directly writing it as BC square is equal to AC plus AC square plus AB square. Second point, we always write what is required to prove. So this is what is required to prove. Now there are different ways to prove a Pythagoras theorem. It can be proved by similarity, it can be proved by solid geometry also, or normal this geometry. But in your textbook, whichever method is given, I will be trying to prove it by that method only. Now one more thing you need to know, suppose this is angle A. So side opposite to angle A can be termed as small a. This is angle B, side opposite to angle B can be termed as small b. This is angle C, side opposite to angle C can be termed as small c. So it means in place of BC you can say A, because BC is how much? A. So we can say A square, because BC square means A square is equal to AC. AC is B, so B square plus AB is C square. Means it can be written like this also. Basically what you have to prove, A square is equal to B square plus C square. Or if you change the name, suppose A comes here, B comes here, C comes here, then this equation may be converted to C square is equal to A square plus B square, or B square is equal to A square plus C square. So there are different, it depends on how you take. Suppose you take PQR, so P, Q and R like that. Now for next point we write construction. Construction. Now what is there in construction? Whatever you do in order to prove, you write it in construction. So first point is we will extend AB to a point D such that AD is equal to AC. Means is equal to, you will construct or extend AB to D such that AC is equal to BD, or that was simply B. So like this what I have done, AB has been extended such that BD is equal to AC. So if this is B, this has to be B. Now on point D, draw a perpendicular. Now on point D, draw a perpendicular and mark it or cut this perpendicular at point E, which is equal to AB. Means like this. Again, on point D, draw perpendicular and cut a point E on it such that DE is equal to AB, and AB is how much? C. So I have made C. Next thing is join BE and CE. Next is join BE and CE. This is the construction, so I am joining BE and CE. Something like this. Now we will prove it. So this is all that construction that we require. Now comes the proof. So in the proof, if we consider two triangles ABC and DEF, ABC and DEF, this is 90 degree by construction and this is 90 degree, it is given, right? These two angles are 90 degree. So we can say, we will write in triangle ABC and triangle ABC BED. In these two triangles, what we are trying to solve, first we will consider these two triangles. In these two triangles, you know that first thing CA is equal to BD by construction, AB is equal to CE by construction, and angle A is 90 and angle D is 90. So what we will say in triangle ABC, first of all we can say AC is equal to BD. Why? Reason we have just now constructed. So construction. Second point is we can say AB is equal to DE, again by the same reason, construction. And next we can say angle A is equal to angle D is equal to 90 degree. Angle A is given 90 degree and angle D we have drawn 90 degree because it is written on point D draw perpendicular. So perpendicular means 90 degree. It means triangle CAB and triangle DEB are congruent by side angle side. Side, 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 side. And included angle and included angle. So we can say that triangle ABC is congruent to triangle BED by SAS rule. If triangles are congruent, means let us draw this separate triangle ABC and this separate triangle BDE. AC is equal to this side BD, AB is equal to this side ED, and this angle 90 and this angle. So it means that angle C will be equal to angle B. Angle C will be equal to angle B. Why? Because when the triangle is congruent, then all the 6 elements of one triangle are equal to the 6 elements of equal to the corresponding 6 elements of the other triangle by CPCT. So we can say that this angle C is equal to this angle B. Anyway, we can say that angle ACB, angle ACB is equal to angle DBE is equal to angle DBE. By what reason? CPCT rule. And one more thing, if this triangle is congruent to this triangle, it means the hypotenuse here, that is A, and here also the hypotenuse is A. So also we can say that BC is equal to BE. One more thing can be written, that we can say, and BC is equal to BE, that will be equal to A, and reason is CPCT. Now this much we have done, or this much we have proved. What we have proved? First of all, we have said that this angle C and angle B are equal. This BC is A and BE is also A. Now we know that triangle in triangle ABC, angle A plus angle B plus angle C is equal to 180 degree. We all know by the angle sum property. So we can say angle CAB plus angle ABC plus angle BCA is equal to 180 degree. Why? Angle sum property. Angle sum property. Now in these three angles, we know that angle A is 90 degree, means this angle is 90 degree. It is given already, right? ABC is the right angle triangle at and right angle at A, means angle A is 90 degree. So in place of this we can say 90, we can write 90 degree plus angle ABC plus angle BCA is equal to 180 degree. 90 goes to that side. So we can finally say that angle ABC plus angle BCA is equal to 90 degree. Why? This total was 180 degree In place of angle A, we have substituted 90 degree. 90 goes to that side, it subtracts. So ABC plus BCA. ABC plus BCA is equal to 180 minus 80. That is 90 degree. Now ABC plus BCA. ABC plus BCA means this angle and this angle. Total of these angles is 90. But previously we have proved that ACB is equal to DBE, means ACB this angle is equal to DBE, means this angle can be replaced by DBE. In this part only, in place of ACB, we can write DBE. So what I am writing, angle ABC plus angle DBE is equal to 90 degree. Why? Since we have proved that angle ACB is equal to angle DBE. That is why in place of angle ACB we are writing angle DBE. So ABC plus DBE. This angle and this angle, total of these two angles is 90 degree. We have just now proved ABC. So that is ABC. This angle and DBE, this angle. Sum of these two angles is 90 degree. Since ABD is a straight line, it means that angle ABC plus angle CBE plus angle DBE is equal to 180 degree. Why? Because it is straight angle. ABC, this angle plus this angle and plus this angle is a straight line or 180 degree. Out of these 180 degree, these two, the total of these two is 90. So this angle is left also 90 degree. So we can say that angle CBE, or what we do, in place of this is one value, in place of ABC and DBE, if I substitute 90, I can say angle CBE plus 90 degree is equal to 180 degree, implies that angle CBE is equal to 90 degree. This is very important result. Now we have proved that this angle is 90 degree. Now I'll just rub it out and then I'll again proceed it. Now we have proved that angle CBE is 90 degree. This angle is 90 degree, that has been proved. This will be required now. Now angle CBE is 90 degree. It implies that triangle CBE is also a right angle triangle. Now what we can see, if you consider ADEC, you see that this angle A is 90, at the same time angle D is 90. It means that AC is parallel to DE. AC is parallel to DE. Why? Because sum of co-interior angles is 180. I hope you remember co-interior angles. Suppose these are two parallel lines and a transversal is passing to them. So this angle and this angle are co-interior angles. And we know that sum of co-interior angles is always 180. Or if the sum of co-interior angles is 180 and a transversal is cutting two straight lines, it means these two straight lines are parallel. If you look at this, you can see that this is a transversal. It is something like this. These two lines are there. This is a transversal cutting. So this angle and this angle, they make co-interior. This make co-interior angles and the sum of them is 180. So according to that rule, angle A plus C is 180. If angle A plus C is 180, then AC and DE will be parallel. So that is what it is written over here. AC is parallel to DC. Now if and AC and DE are parallel, it means ADEF can be considered as a trapezium. We can say that therefore ADEC is a trapezium. And because we know that what is a trapezium, any quadrilateral whose one pair of parallel sides, whose one pair of sides is parallel, it is known as trapezium. So you can see in ADEC one pair of sides is parallel, but we cannot say anything about the second side. Now if it is a trapezium, if I want to find the area of the trapezium, we can say area of trapezium. Which trapezium? ADEC can be written as area of triangle ABC plus area of triangle CBE plus area of triangle EBD. This total ADEC can be written as area of this triangle, first one, area of second triangle plus area of third triangle. If we add the area of all these triangles, we will get the area of trapezium. We know that area of trapezium is half into sum of parallel sides into distance between them, or into distance, or you can say into distance. I'm not writing between them, this makes the sense. Now area of ABC, since ABC is a right angle triangle, we know that area of a triangle is half into base into height. So half into base is AB and height is AC, plus area of triangle CBE. So CBE, in which one angle is 90. So I have already said that triangle CB is also right angle triangle. If this is a right angle triangle, so obviously the side opposite to it is CE. So CE is the hypotenuse. It means base can be considered as BE and perpendicular can be considered as DC. So half into base of triangle CB, I am taking BE as base and perpendicular as BC, plus half of triangle EBD. Now EBD, base is BD and perpendicular is ED. So base is into BD. This area of trapezium can be written as area of triangle 1 plus area of triangle 2 plus area of triangle 3. Area of triangle 1 half into base into height, half into base AB AC, AB AC. Second, half into base BE into CD, BC into BC, BE into BC, plus half of BD into ED. Now sum of parallel sides. One parallel side is AC plus other parallel side is DE, because we have proved that these are parallel. DE into distance between them is AD into AD is equal to half into value of AB is C, value of AC is B, plus half BE. BE is A and BC is also A, plus half BD. BD is B and ED is C. Now here also we substitute the values. Half AC is how much? AC is B, plus DE is also C. DE is C into AD is B plus C. So it becomes B plus C is AD is equal to, if I take half common from all these three, what will be left? BC plus A square plus BC. Now this half and this half will cancel. This will be b plus c whole square. This can be written as bc, and bc is 2 times of bc plus a square. Now when you apply a plus b whole square, b plus c square will be written as b square plus c square plus 2bc is equal to 2bc plus a square. 2bc and 2bc cancelled. Finally you got a square is equal to b square plus c square, and that is what was required to prove. Now a square is what? bc square. So in place of a we can write bc square is equal to b square. In the original triangle, b square is ac square, and plus c square is ab square. That is what was required to prove. So this is the proof of Pythagoras theorem. This is very important. You need to remember this. It may be given in the exam that you need to prove, or you need to write the Pythagoras theorem, or in any way it can be asked, or maybe questions based on them. It is very sure that questions based on them will be there. Okay, so we have discussed Pythagoras theorem today, and this is all for today. In the next class, we will be discussing converse of Pythagoras. That is also very important. And then we will move on to the exercise. This is the last chapter before half yearlies. So stay blessed. Keep on watching. Keep on studying hard. Keep on practicing. And in case you have any doubt, you can send me your problems on this number. Thank you all of you.